Breaking news. At precisely 0241 UTC this morning, an automated sky survey operating out of Cerro Paranal in northern Chile flagged an object that should not exist. Within seconds, confirmation alerts cascaded across global observatories, from the Atacama Large Millimeter Array to ESA's Deep Space Tracking Stations in New Norcia, Australia. What they saw was not subtle. A massive object, more than 100 times larger than 3I Atlas, had entered the inner solar system at extreme velocity. And moments ago, trajectory analysis revealed something far more unsettling. Its path was not random. Today, the impossible just happened. The object is aligning, deliberately, toward 3I Atlas. This changes everything we thought we knew about interstellar visitors. If you want real-time updates as this story unfolds, hit like, subscribe, and stay with us. What we are witnessing may redefine our place in the universe. Within minutes of the initial alert, emergency coordination protocols were activated across NASA, ESA, and partner institutions worldwide. Data feeds were opened to Harvard's Center for Astrophysics, Caltech's Jet Propulsion Laboratory, and the European Space Network. The James Webb Space Telescope, currently positioned at the Sun-Earth L2 point, was retasked mid-observation, interrupting a scheduled exoplanet survey to lock on to the incoming anomaly. Hubble followed seconds later, pivoting its optics to capture visible spectrum confirmation. From South America, radio arrays in Chile swept the object's frequency footprint, while infrared instruments in Hawaii and the Canary Islands attempted thermal characterization. Across 3 continents, the readings converged. This was no artifact, no glitch. The mass estimates alone stunned analysts, roughly 100 times the inferred mass of 3I Atlas, with a cross-sectional diameter approaching 1,200 kilometers. And yet, it emitted almost no thermal signature. To understand the gravity of this moment, we need to step back. 3I Atlas itself was already an anomaly, an interstellar object with unusual acceleration profiles, unexplained mass loss, and machine-like precision in its trajectory. Now, something vastly larger has arrived. According to early orbital solutions generated at Caltech, the newcomer entered the heliosphere on a hyperbolic path with a velocity exceeding 68 kilometers per second. That alone was extraordinary. But when ESA's dynamics team overlaid its projected course with known objects, a chilling pattern emerged. The probability that this object would pass within 0.03 astronomical units of 3I Atlas by chance was calculated at less than 1 in 10 billion. This was not coincidence. Before we even had a name for it, the data suggested intent. 48 hours before the official detection, subtle clues were already present, missed at the time, now glaring in retrospect. Archival data from the Atacama Array showed faint gravitational perturbations in the outer Kuiper belt, as if a massive body had passed through without emitting light or radiation. 11 hours later, a deep space probe operated by ESA recorded anomalous fluctuations in local space-time curvature, measured as deviations in nano-Tesla-scale magnetic fields, far beyond what solar activity could explain. At the time, analysts attributed the noise to instrument drift. They were wrong. 6 hours before detection, infrared telescopes picked up a cold void moving against the cosmic background, absorbing starlight rather than reflecting it. And then, 1 minute ago, everything aligned. At 0241 UTC, the object crossed the heliopause. Its entry produced no shockwave, no flare, no ionization trail. Instead, it slipped through as if the boundary were irrelevant. Initial spectroscopic analysis revealed something unprecedented. The object's surface, or whatever constituted its outer boundary, exhibited spectral absorption lines that did not correspond to any known element or compound. Not dark matter, not antimatter, something else. Its temperature was measured at just 12 Kelvin, barely above absolute zero, despite its immense size and velocity. According to every known law of physics, an object moving this fast through interstellar space should be heating up. This one was cooling. As the hours progressed, scientists began tracking its motion in real time. At 14 hours post-entry, its acceleration profile changed, subtly but measurably.
Without any detectable thrust plume, without ejecting mass, the object altered its velocity vector by 0.4 degrees. That adjustment alone required an energy expenditure equivalent to the output of a small star over several seconds. No natural process could produce such controlled redirection. At this point, the comparison to 3I Atlas became unavoidable. Both objects exhibited silent motion. Both defied conservation expectations, and now they were converging. Inside NASA's Jet Propulsion Laboratory, simulations ran continuously. Gravitational modeling suggested that if the larger object were purely inert, solar influence would dominate its path. Instead, the object resisted gravitational pull with uncanny precision. Dr. Elias Morano, a theoretical physicist collaborating between Harvard and ESA, described it bluntly in a closed briefing. It's navigating. His statement was met with silence, not disbelief, worse, recognition, because the numbers supported him. The object corrected its course every 37 minutes, each adjustment identical in magnitude, as if following a programmed sequence. Meanwhile, attention returned to 3I Atlas. 48 hours before the larger object's arrival, 3I Atlas itself began behaving differently. Its rotational period slowed from 4.1 hours to exactly 6.000 hours, no variance. Its electromagnetic emissions, previously chaotic, settled into a narrow-band pulse repeating every 73 seconds. That interval is mathematically significant, the 21st prime number multiplied by itself. At first, analysts dismissed the pattern as coincidence, but when the pulses synchronized precisely with each course correction of the incoming object, coincidence was no longer an option. This was no longer random, it was responding.
Two competing hypotheses rapidly formed. The mainstream explanation, championed by Dr. Lila Chen at Caltech, proposed an exotic but natural origin. She suggested the larger object could be a primordial relic, an ultra-dense fragment of early universe matter interacting with space-time in ways we do not yet understand. According to her models, quantum vacuum effects could theoretically allow for self-stabilizing motion without propulsion. It was elegant, it was safe, and it required physics that humanity had not yet proven but could imagine. The alternative hypothesis was less comfortable. Dr. Henrik Volkov of the European Space Agency posed it carefully. What if both objects were technological? Not spacecraft in the cinematic sense, but probes, ancient, autonomous, and purposeful. Not alive, perhaps, but not natural. As debates intensified, the universe seemed to answer back. At 26 hours after detection, the larger object emitted its first signal. Not radio in the conventional sense, but a burst of low-frequency gravitational waves, short, precise, and repeating. Detectors in Italy and Japan recorded the pattern simultaneously. The waveform encoded a simple mathematical structure, prime numbers ascending, then resetting. This contradicted every natural model proposed so far. Gravitational waves are not emitted casually. They require catastrophic events, black hole mergers, neutron-star collisions, and yet here they were, controlled and precise. Within minutes, 3I Atlas responded. Its electromagnetic pulse shifted phase, aligning perfectly with the incoming wave. Control rooms around the world fell silent. Internal communications were encrypted. Agencies stopped issuing public statements. In the absence of information, speculation exploded. But inside the data, something even more troubling emerged. The larger object adjusted its trajectory again, not just toward 3I Atlas, but in a way that placed Earth within the same plane of alignment. Not a collision course, an observational one. Satellites in low Earth orbit began experiencing brief communication dropouts, lasting milliseconds. GPS timing signals showed microsecond discrepancies. Birds altered migratory paths days ahead of schedule. Subtle effects, but global. At 51 hours post-detection, one fragment of 3I Atlas vanished. No explosion, no debris. One moment it was there, tracked across optical, infrared, and radio spectra. The next, it was gone, removed from every sensor simultaneously. The larger object slowed. Its velocity dropped by 2 kilometers per second without any detectable interaction. Energy accounting failed.
Conservation laws broke down. Whatever this was, it was not consuming mass or releasing energy in ways we could measure. It was exchanging information. In the calm after the data storm, a quieter realization set in. Humanity has always assumed that if something advanced existed out there, it would announce itself dramatically. But what if intelligence prefers subtlety? What if we are not witnessing an invasion, but a rendezvous? Maybe we're not witnessing the end, but an invitation. An interaction between machines older than our species, operating on timescales that make our history seem like a blink. The universe, long silent, may be revealing that it has been active all along. As I stare at the latest feed, one final update comes in. The larger object has completed its deceleration. It is now holding position relative to 3I Atlas. The distance between them is closing, slowly, deliberately. No signals, no light, just alignment. And that raises a question we are not prepared to answer. What happens when they finally meet? Subscribe to follow the next update, because whatever this is, the story isn't over.